Tirthankar Lahiri, hi, welcome to our interview.
Thank you.
Scalability is always a topic in the IT world and especially for databases. What's your definition of scalability?
That's a very good question. Scalability is actually a multifaceted attribute. A system that's truly scalable has to scale in multiple dimensions. The first thing it has to do is to scale up to use all the available CPU cores in its particular machine. Once you've consumed the CPU cores efficiently, then that system has to scale out across multiple independent hosts for maximum performance. And once you start to do that, you need to make sure you replicate your systems as well for fault tolerance. So scale up, scale out, replication are the three first steps for scalability. And then inevitably, you get into a situation where you run into the limits of a single database or a single database architecture. And that's when you have to start to shard across multiple independent logical databases that operate together as one. So scalability basically is four different things. It's scale up, it is scale out, it is replication, and it is sharding. I hope that answers the question. It's a long answer to a short question.
Yes, because most times when you hear the term scalability, it's in a negative way.
Yes.
Your system does not scale, or this does not scale to the expectations.
Yes.
But the positive aspect is important. And I think Oracle has a good portfolio for that.
Yes. I think a lot of systems claim scalability because they scale out across many different independent compute nodes. What they often fail to point out is that they can't use all the CPU cores efficient on a single host. So many systems actually run only on 1 or 2 core machines because they can't scale up more than that. And so they need multiple nodes just to get good performance. With Oracle Database, it's been a day one goal to maximize the use of all the CPU cores. So we have scaled up to systems with hundreds of cores, thousands of cores effectively. And only once you run out of headroom on one host, should you need multiple hosts for performance. A lot of customers use multiple hosts for fault tolerance. That's a different problem. But scalability shouldn't require multiple hosts right away. You first maximize a single computer, then you use more than one computer for scale out, then you replicate fault tolerance. And for very large global scale applications that need to run in multiple sites, multiple regions, that's when you add sharding to the equation to get the ultimate hyperscale architecture.
Yes, and I think the big challenge is to enable this not only for one single task, right? So it's important to do it for all kinds of workloads.
Oh, yes, yes.
And I heard there is something that's called the Converged database.
Yes, yes.
So can you tell me about that?
Sure, actually, you're right. If you have a gigantic hyperscale database that's running in multiple regions, it's a huge waste if all it can do is one thing. That's like a gigantic waste of resources. So Oracle's strategy is to provide what we call a converged database architecture, which allows you to use the same underlying infrastructure to run many different types of workloads, relational workloads, analytic workloads, transactional workloads, document, graph, spatial, etc. So that's the strategy, is to provide one engine that can run all these workloads and data models simultaneously without requiring multiple disjoint database systems to be set up for different use cases.
So the Converged database, is this an Oracle product, or is this an addition, or what's that?
Yeah, Converged database really is the name of an architecture.
Okay.
It's not a separate product or a separate addition. Oracle from day one has had convergence in its horizons. It's always been a converged database running multi-model workloads. It really is a consolidation of different types of processing, different types of data types. Oracle, was one of the first databases to add objects, for instance, back in the 90s. And now we have JSON, we have spatial data support, graph. They're all add to this architecture, enrich the basic architecture with multiple flavors of data and data models. So yes, it's not a different product, it's not a different edition, it's basically Oracle database itself.
Okay, so when we talk about the Converged database as a concept or as an architecture, what's the real advantage over single purpose databases? Because it sounds complex.
Good question. Okay, so I have an analogy. So I live in a house. I have different rooms in my house which do for different purposes. I have a living room and a bedroom and a bathroom and a kitchen. I could have also built 4 separate houses. One for cooking in, one for living in, one for sleeping in, and one for bathing in. Arguably, the latter model would have made it very easy to develop single-purpose houses that I would walk between to get my job done. It's a very similar concept with data management. If I have 4 different databases for graph, for documents, relational, analytics, I push the problem back to the user and the IT architect.
Until the integration.
Right. Suddenly now I have to integrate data between these systems because I can no longer just seamlessly move data back and forth. I need a separate security policy for each independent system, secure them independently. It creates a massive risk because any security protocol will tell you that your security is defined by the weakest link in the system. So security gets compromised. Atomicity of work gets compromised. Asset properties, if I want to run a transactional workflow that touches 4 different databases, it's the application's job now to keep that workflow consistent. Also just manageability. Suddenly I have 4 complete different systems to manage. I might have redundant data in different systems also, so it makes it very difficult to run reports. So to me, it's just like living in one house versus 4 different houses. So I personally think one house works much better. You do need different algorithms. You do need different data models for different use cases. What you do not need is different engines. And I think the single-purpose systems, they're good at what they do individually, but they create a gigantic problem for the overall IT architect of integration, of security, of diagnosability, of patching and maintenance and upgrades.
Yeah, so I think also the world is not black and white. So you have also hybrid data. You have data that it's not classified as being only spatial. It's not classified being only XML. So you have always gray zones where the integration is a challenge. But on the other hand, doesn't exactly this multi-purpose approach make people who only need a part of it, for example, to patch it all? So because when I'm not using all the components of the Converged database, but I have the security problems of all of them, how do you address that problem?
Well, the thing is, the way I see it is with Converged database, you solve the basic IT problems once. And you secure them, you build robust diagnosability mechanisms, manageability. It's like I build one alarm system for my entire house. I secure the house, all my rooms are secure. As opposed to taking each independent room and building separate schemes for each. So even if you're using only one part of the house at any given time, like I often do, I don't live in all the rooms simultaneously, it's still good to know that there's only one mechanism needed to secure everything simultaneously. So especially now with autonomous database, where we can deliver a database on cloud scale that is very easy to manage. The old days of managing databases sort of going away with cloud. Autonomous database gives you a huge advantage in making it very simple to access Oracle databases, and you can use whatever subset you want. I would claim that would solve your problems. Now, it is still possible to complement the architecture with single-purpose databases, and many customers do that. There's nothing wrong with that, as long as that's not the default choice. The way I see it is you want the Converged platform to be the default platform, and you can certainly add other solutions around it to complement the architecture if you need to. But it's better if those are well thought through, use case by use case, than just being done blindly to make your evolution of the architecture more seamless and more more logical.
So it's your recommendation to go for the autonomous database when you need the converged architecture, or what is your real world approach to using it and to implementing it?
Autonomous database makes converged database very accessible. It's easy to access. Now, if you have an Oracle database, in-house, which you're already using, of course you can keep using that. ADB just takes away some of the work required to set up, administer, upgrade, patch the database, because that's all done for you by the cloud infrastructure. So yes, it's a great way to onboard with the converged architecture. And now with autonomous database, the ramp to getting a running application is much shorter than before. So it's very easy to manage. It's self-serve. You can set up an autonomous database in minutes today on the cloud. And you can run very complex workloads, which you really can't run on other systems. Like you can't take an instance of MongoDB, for instance, and have it run relational, graph, and spatial together. With autonomous database, you just bring up the application, and you can add SQLs as you need for spatial, graph, machine learning, etc., without creating new database instances. So it's a much easier application architecture to evolve in the long run. Because as you and I both know, nothing stays simple. You might begin something simple. The real world is not simple. So everybody thinks that this is my only use case. And they eventually found that there's more than what they need that they have to add later on. So ADB is a great way to smoothly add functionality by having a very easy entry to setting up an Oracle database.
Yeah, so it's still not a silver bullet, but you have to know what you do. But it's a good platform to do the work and prepare your enterprise for the future.
Right. It's a great way to get started. It takes away a lot of the trial and error and the mechanical parts of setting up an Oracle installation. And then you can really focus on the business logic and work on the business needs as opposed to worrying about day-to-day maintenance and security and other tasks like that.
Okay. Tirthankar, thank you very much. It was an interesting talk.
Okay.
And I'm looking forward to talking to you in the future as well.
Good.
Have a good time.
Good.
Goodbye.
Bye-bye.